Yes, sir.
Okay, good. Okay, so let's start with alkaline fuel cell. So remember, every unit will have questions of up to from 16 to 20 marks. Okay, in SCE, so semester and examination. So contribution of each unit will be from 16 to 20 marks. So there could be questions in quiz section from 2 to 4 marks and questions up to 16 marks in part B. So coming to part B, the general questions from this unit can be uh, asking you to explain about a certain type of fuel cell. How does it work? What are the advantages, disadvantages, applications, working principle, types, so on and so forth. So remember this, irrespective of how the question is framed, the moment you come to know that the question is related to a specific type of fuel cell, you have to invariably list the following things. So what is the first thing? You will provide an overview of that fuel cell. So what will that overview include? So the one what you can see on the slide right now. So that is operating temperature. The range should be mentioned. The current density, high, moderate or low should be mentioned. So electrodes, what are the types of electrodes that are used? Then charge carrier, water management, applications, advantages and disadvantages. So these are the points that you are going to list under overview. Okay, so irrespective of the type of fuel cell, however the question is framed, you are going to start with an overview. So it is going to be very brief. So you will provide all these points: operating temperature, current density, electrodes, charge carrier, water management, advantages, disadvantages, and applications. So these are the points under overview. Once you complete the overview, you have to give schematic representation of the fuel cell. It need not be a 3D sophisticated representation. Let it be as simple as possible, 2D representation, but schematic representation is a must. So once you give the schematic representation, you label the components. That is also important. So clearly indicate the electrodes, electrolyte, at which electrode fuel is entering and at which electrode oxidant is entering, direction of flow of electrons. All those things should be clearly mentioned or shown in the schematic representation. So after giving the schematic representation, you should definitely write the reactions. So reaction at anode, reaction at cathode, and the overall reaction. So these three reactions are important. So do not mix and match. Do not get confused. You have to practice. Okay, write the reactions. Once the reactions are done, you have to give brief description of that fuel cell. It could be working principle or how that fuel cell works. So you have to briefly explain that. After the description, you have to talk about the whatever you listed in overview. All those points should be covered. So after the description, you will talk about the electrodes, advantages, disadvantages, and applications. So what is the quantity of information that you are going to provide, how elaborative it is, that depends on the marks. Whether the question in part B is for 6, 8, 10, or 12 marks. So irrespective of the marks, all these subtopics should be listed. However, information under all these subtopics depends on the marks. If it is for 10 and 12 marks, you will give more details. If it is for 6 or 8 marks, accordingly, you will just reduce the information, but not the subheadings. Okay, pay attention. This is a theory course. The more you write, the better it is. So all the points should be listed, right? Okay, we are talking about questions in part B from unit 2. So irrespective of how the question is framed, and irrespective of the type of fuel cell, you have to list these things. Start with the overview, then schematic representation, reactions, brief description or working principle of the fuel cell, advantages, disadvantages, and applications. I hope this is clear. So with that, let's continue with the alkaline fuel cell. So coming to the overview, the operating temperature is listed, the whatever operating temperature that is listed, it varies from books to books. Okay, so it might be different in different books. So whatever range that is provided here is the widest range. So in general, alkaline fuel cell is considered as low temperature fuel cell, and it works close to room temperature. The maximum temperature might go up to 100 degrees centigrade. However, there are examples in the past where the same alkaline fuel cell was operated even at a temperature of 200 degrees 260 degrees centigrade. So here the range is 53 to 373 Kelvin. Usually it operates at a temperature close to room temperature. Maximum it goes up to 100 degrees centigrade. That is with respect to operating temperature. And based on that operating temperature, it is categorized as low temperature fuel cell. Coming to current density. So what is current density? Current per unit area. If nothing is mentioned about unit area, it will be unit area of the electrode. There is a possibility that the current density can be expressed in terms of unit area of electrolyte as well. Usually when the electrolyte is a solid electrolyte, that is possible. And many of you are trying to join the class using IDs other than RVC ID. So kindly use RVC mail IDs to join the class. Okay. Yeah, coming to current density, it is current per unit area of the electrode, and such current density in case of alkaline fuel cell is high. Okay, what are the other possibilities? Moderate and low. That depends on the type of fuel cell. In this case, the current density is high. We are going to discuss more details about that in the following sections. Coming to the electrodes that are used, so nickel electrode and alloys of nickel. Okay, so these are the possibilities when it comes to electrodes. Charge carriers. So hydroxyl ions or OH minus ions are the charge carriers. So water management, water that is generated is usually evaporated. So applications, known applications are military and space. So advantages, the electrodes need not be noble metals. No bipolar plates are required. Electrolyte is less corrosive. These are some of the advantages. Disadvantages, the fuel should be pure. This is the disadvantage of alkaline fuel cell, and fuel should not contain oxides of carbon. These are some of the disadvantages of alkaline fuel cells. So now we have covered the overview. So let's proceed. So after the overview, we should give the schematic representation. So it need not be a representation like this, what you see on the screen. So this is a 3D representation, not necessary. It can be two-dimensional representation. And once you give the representation, clearly indicate the components. So as usual, anode, cathode, electrolyte, fuel, oxidant, load, flow of electrons, flow of ions. So we can indicate the electrons as E minus and ions as OH minus, which pass through the electrolyte. So now coming to the reactions. The reaction that is taking place at anode is the fuel hydrogen reacts with OH minus ions forming water and electrons. So the electrons that are generated at anode pass through the external circuit and reach cathode. The ions, the OH minus ions, are circulated through the electrolyte. So coming to the reaction at cathode, oxidant, that is oxygen, combines with the electrons that came across the external circuit with water for regenerating hydroxyl ions. The hydroxyl ions that got regenerated at cathode move through the electrolyte and reach anode to complete the circuit. This is about the reactions. Okay, and coming to the electrolyte, so the name itself indicates that it is alkaline fuel cell, meaning the electrolyte that is used is an alkaline solution. So sodium hydroxide and potassium hydroxide are the potential electrolyte candidates for AFC. So at times it could be a mixture of the two. In some cases it is sodium hydroxide and mostly it is potassium hydroxide. So if you compare usage of sodium hydroxide and potassium hydroxide, so potassium hydroxide has additional benefits. So at some point of time, the carbonate formation is observed. So potassium carbonate is formed. In such a case, potassium carbonate is more soluble than sodium carbonate. For this reason, among the two, that is NaOH and KOH, so potassium hydroxide is preferred or most commonly used. Also, these two are one of the cheapest chemicals that are available for electrolytes. Among the two, potassium hydroxide is comparatively even less cheaper than sodium hydroxide. So this is the reason why alkaline fuel cell is comparatively cheaper than other fuel cells. So there are few more reasons, and I'm going to mention that as well. So now we are concentrating on the electrolyte. So low cost, high solubility, low corrosivity are some of the reasons or benefits or advantages of alkaline fuel cells. So now going to the history of alkaline fuel cell, it was first discovered in 1902. However, there were no potential applications till 1940. From 1940 to 1960, so a lot of research was carried out on alkaline fuel cells, and a person by name Francis Bacon carried out a lot of research and showed many demonstrations using alkaline fuel cell. The demonstrations included running a tractor, so powering a welding machine, and few cars were powered using this alkaline fuel cell. Because of these demonstrations, research on alkaline fuel cell gained little momentum during that time, and finally US government decided to use the alkaline fuel cell to power the first uh, mission to moon, that is Apollo spacecraft was powered by alkaline fuel cells. It is not only powering the spacecraft, so the potable water requirement on board was mostly fulfilled by the water that was generated from this alkaline fuel cell. So that was the first large scale application of alkaline fuel cell. So Apollo spacecraft, so which carried man to moon, was powered by alkaline fuel cell. And later, uh, based on the experience of using Apollo using AFC in Apollo. So orbiter was also powered by alkaline fuel cell. And Apollo was operated at a temperature of 200 degrees centigrade, and the orbiter was operated at 90 degrees centigrade. From then onwards, the operating temperature of alkaline fuel cell was restricted to less than 100 degrees centigrade. Okay, then especially in case of demonstration models, it worked well. However, because of these demonstrations, people started doing extensive research on alkaline fuel cells. Later, they realized there are some of the engineering problems associated with scaling up or commercializing alkaline fuel cells. So what were those? So the reliability, then ease of use, so how rugged or robust the system is, and safety. These were some of the issues that were identified as engineering problems by researchers. So, besides this, by that time, the polymer electrolyte membrane fuel cell started popping up. It started gaining importance. Because of that, and also associated engineering problems, people started uh, losing interest on alkaline fuel cell. So success of PMFC led to the decline of interest on AFCs. So that is about the history of AFC. And coming to the advantages, okay, we realized that the electrolyte is less corrosive, and also it is one of the cheapest chemicals that can be used as electrolytes. So we already know that advantage. Also, it is less corrosive. Then followed by that, we are going to discuss about the types of losses associated with fuel cells. So one such type of loss is activation loss or activation overvoltage. So the loss is also defined as overvoltage. So when it comes to that type of loss, usually in the fuel cells which operate at temperatures close to room temperature or operate at temperatures less than 100 degrees centigrade, the activation losses are more. However, in case of alkaline fuel cell, that activation overvoltage or activation loss is less. That is also considered as an advantage. So soon we are going to learn what is this loss, so what is its impact, how to control that, everything we are going to discuss. But for now, just remember that activation loss in case of alkaline fuel cell is less, so that is considered as one of the advantages. And while discussing about the electromotive force or voltage or open circuit voltage about a fuel cell, we realize that in a conventional hydrogen oxygen fuel cell, when hydrogen is used as fuel, the open circuit voltage is around 1.14 volts. However, that is open circuit voltage. When you connect a load to it, so there will be a sudden drastic drop in voltage, and operating voltages on an average will be around 0.6 to 0.7. Such an operating voltage in case of alkaline fuel cell is as high as 0.875 volt. Again, that is considered as an advantage. So whatever we discussed, that 1.14 volt is open circuit voltage, right? But now we are talking about operating voltages, the voltage that is observed when load is drawing current from the fuel cell. Okay, so by now we have learned two types of voltages. One is open circuit voltage, another one is the operating voltage. There is one more voltage we are going to learn soon, that is no loss voltage or theoretical maximum voltage. So there will be three types of voltages that will be taken into account always. So far we have learnt two. One is the open circuit voltage, other one is the operating voltage. Such an operating voltage in case of alkaline fuel cell is 0.875 volts. And as I mentioned earlier, the cost of electrolyte in case of AFC is very less. And another advantage is, so far the conventional hydrogen oxygen fuel cell, whatever we discussed, makes use of platinum as electrode. So the most primitive fuel cell, the entire electrode is made of platinum. Later we also learned that it is not necessary to use or make the entire electrode with platinum. So you can use substrates such as carbon, graphite or other materials, and you can deposit platinum on such substrate material. Thereby you will bring down the cost, the associated cost. So but when it comes to AFC, such expensive electrodes are not necessary. Platinum is not necessary. Non-noble metals such as nickel and oxides of nickel or alloys of nickel can be effectively used as electrodes in AFC. That is another advantage. The last advantage is there are no bipolar plates. So in unit 1, we discussed about the role of a bipolar plate. So we learned that one fuel cell cannot fulfill the power requirement. For that reason, you will end up stacking fuel cells, connecting multiple fuel cells. While connecting multiple fuel cells, you will make use of a component called bipolar plate. So such a bipolar plate plays a very important role because it is going to sit between anode on one side and cathode on another side. So the material compatibility is a challenge. Usually the electrode material will be different. That means anode material will be different from cathode material. So to accommodate a bipolar plate that has compatibility with both anode and cathode material, so it makes it expensive. So such bipolar plate is not present in alkaline fuel cell. That is again one more reason for low cost. So these are some of the advantages of alkaline fuel cell. So electrode cost, electrolyte cost, so absence of bipolar plate, little loss because of activation, and high operating voltage. These are some of the reasons why alkaline fuel cell gained importance in 1940s or 50s. Okay, with that, let's proceed to the electrodes. Let's learn a little more information about the electrodes. Okay, so coming to the electrolyte, we just realized that nickel is a potential candidate. So, however, how is it fabricated? So, are there any different types of electrodes based on this nickel alone? Is what we are going to learn now. Okay, so sintered nickel powder is one type of fabricating the electrode. So, what happens here? Nickel powder is considered. It is sintered to make porous, rigid structure. So that is give, uh, giving this powder a shape by using various binders. You use binder material, mix that powder with binder and subject that to heat treatment so that you get a porous, rigid structure. And in this case, the particle size distribution of the nickel powder depends upon the type of or which electrode it is, whether it is anode or cathode. And also, one side of the electrode is always exposed to gas, either fuel or oxidant. The other side is exposed to electrolyte, which is liquid. So based on this, the size of this nickel powder is selected. So one for gas side, another for electrode side. So like that, nickel powder of different particle size distribution is considered. So using a binder, a shape is given to that that is subjected to heat treatment so that a porous rigid structure is formed. Porosity is of utmost importance in case of any electrode for that matter when it comes to fuel cell. So this is one type. So next is Rane metals. This is another category. So where mixture of two metals. So an active metal and inactive metal. So active metal is nickel, inactive metal is aluminum. So a mixture is made of these two metals. You do not really call this as an alloy. So it is like considering nickel powder and aluminum powder, mixing it, subjecting it to heat treatment. So you mild by mild heat treatment, you will fuse the material, and later you will try to take out the inactive metal. So you form the structure using two metals, active metal and inactive metal. Once the structure is formed, so that structure is subjected to action of a chemical such as strong alkali, so which will take out all the aluminum. Because of this, a highly porous structure is formed. And also for this reason, it is not considered as a true alloy. And you can clearly make out distinct regions of aluminum and nickel on that surface. And once you dip such a structure in a strong alkali, so all the aluminum is taken out and a porous, highly porous electrode structure is obtained. So that is about a variant in AFC electrode known as Rane metals. The third is rolled electrodes. So what happens here? You use a support material such as substrate like carbon, and you use a binder, that is PTFE. So polytetrafluoroethylene is a binder which acts as a glue or which facilitates binding between the substrate and the actual electrode material. So such mixture is made and that is casted or rolled onto a mesh made of nickel. So you take nickel mesh, so prepare a mixture of the carbon substrate and the binder PTFE. You cast it or roll it on the nickel mesh to form the electrode. And sometimes carbon fibers are added, which provides additional strength, makes it more conductive, and provides surface roughness as well. So this is the third category, that is rolled electrodes. So the electrodes are formed, casted, fabricated by rolling the mixture of carbon and PTFE binder on nickel mesh. So these are the variants of electrodes. Next is coming to the types of the alkaline fuel cells itself. So we are not going to discuss anything in detail about that, but this is just for your information. Mobile electrolyte alkaline fuel cell, static electrolyte alkaline fuel cell, dissolved fuel alkaline fuel cell. These are the three types of alkaline fuel cells that are available. Okay, that is just for your information. So now let's look at the disadvantages of alkaline fuel cells. So one of the major disadvantage of AFC is if the fuel contains carbon dioxide, the hydrogen, if it contains even traces of carbon dioxide, so that is not acceptable. The carbon dioxide present in fuel reacts with the electrolyte forming carbonate. Okay, so if the electrolyte is potassium, potassium carbonate is formed, and if the electrolyte is sodium hydroxide, then sodium carbonate is formed. Comparatively between the two, the sodium carbonate is less soluble, tends to precipitate and gets settled down. Potassium carbonate is comparatively soluble. So what happens when the carbon dioxide is present? This carbon dioxide reacts with the electrolyte. Availability of electrolyte and hydroxyl ions get reduced. So instead of liquid electrolyte, so it will have precipitate of carbonate at the bottom, which brings down the flowability of the electrolyte, and the viscosity of the electrolyte increases for that reason, and oxygen solubility is also reduced, which enhances or increases the activation losses. So these are some of the disadvantages of alkaline fuel cell. Okay, so this is all about the alkaline fuel cell. So we learned what are the components, what are the reactions, how does it look like, advantages, disadvantages, brief applications, types of electrodes, types of alkaline fuel cells, so on and so forth.